Hey guys, so in this video I'll be going over the popular two-sum question from LeetCode. So let's start by reading through this question here. So two-sum, given an array of integers, nums, and an integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Okay, so let's look at the examples here. So given this one here, so we have nums, which has these four elements, and our target is 9, and the output is 0 and 1, because the nums at index 0 plus nums at index 1 is equal to 9. So we can see that. So this is element 0, and this is element 1, and 2 plus 7 is 9, and so return 0 and 1. Okay. And let's look at the second one here. So we have 3, 2, and 4, and our target is 6. And our output is 1 and 2. So it would be this 2 and this 4 here. And so this is, I guess, the first edge case here where you may not use the same element twice. So you can't use 3 twice. So you can't just say 0, 0 and then output, because 3 plus 3 is 6, but they have to be two different numbers, two different elements. Okay. And then here we have another sort of edge case, 3, 3. So I guess it's different from this case because they're different indices, right? So we can't use the same element twice, but if the same number appears twice, then you can use each of those. Okay, and you can assume that each input would have exactly one solution. Okay, so you'll always have a solution, and then there's not more than one solution. Okay, so let's go to our drawing board. Let me grab all of this here and paste this in here. Okay, so let's start working through. So now we understand the problem. So at this point, let's go ahead and try to understand potential solutions. So let's just grab the first example here, 2, 7, 11, and 15. Okay, so I guess the most brute force solution here, which is usually the first one that I come up with, is just to basically check every pair, right? So you check, is 2 and 7 equal to 9? Assuming that, let's just pretend that it's not, then we'll go to the next one and compare 2 and 11, and we see that that's not equal to 9, so then we go to 2 and 15, and then we reach the end of the array, so then we go to the next element here, and then we start from 7, so 7, 11, 7, 15, and then you just keep going through, and that will give us a runtime of O of n squared, because you can imagine we're going to have two for loops nested within each other, and so we'll have an n squared runtime. Another way we might be able to solve this would be, if we sort this array. So in this case, it's already sorted, but imagine it's not sorted, and here, it doesn't say anything about being sorted. So the first step would be to sort the array, and we know from our algorithms class that that is n log n, which is better than n squared. And then at this point, now that you know that the array is sorted, you can do some kind of two-pointer solution where you basically have a pointer at the first index, and a pointer at the last element, and you slowly bring them closer together um, as you try to find the solution. So, 15 plus 2 is 17, which is bigger than the target. So we're going to go ahead and move our arrow left. And then 2 and 11 is 13, too big. So we'll move left again, and then we'll find our answer here. And this would be sort of a greedy algorithm after the sorting, because you're guaranteed to sort of close in on our solution, right? If it's too big, we go left to decrease the number. If it's too small, then we go to the right, and that will increase the value. Okay, so there's actually a better solution here than n log n, and that solution is a O of n runtime. So this solution is very similar to problems that you'll see in other problems, or a solution that you'll see in other problems, and that's making use of a hash map to sort of store some data that we process as we go through the loop. And so we'll try to do this in a single pass here. So the way we do this will be, so we have our this guy here. So we have our array here, and we have our target, which is 9. And so you can imagine we have some kind of hash map here. Draw that here. And we're going to basically go through each element once. And at each element, so we're going to start here at the 2. And you basically know, so yeah, so we'll go through this first element, and we'll basically save in this hash map whatever pair will make a solution. So what I mean by that is, so if we have a 2, and we know that the target is 9, then we know that the missing pair is a 7, right? Because 2 plus something will equal 9. So we know we're looking for a 7 in the rest of the array. And so we can basically store that information. So we're looking for a 7. So let's put that in here. So we're looking for a 7. And then the actual solution here is going to be the index. So we're going to need the index for this value when we are ready to output our solution. So let's go ahead and save that index here as well. Okay. So when we do find 7, which we find in our next, so we'll go to the next element here. That's a 7. And we look in our hash map and we find that we have a 7 here. And so at this point, we know that we have a solution. So you can grab the index at our current value, which is 1. You can grab the index for its pair that we saved earlier, which is, we know, is 0. And we can go ahead and output 0 and 1. Okay. Now let's assume that our target is not this, but something like 17. So let's say it's not this, but it's 17. And then at this point, we'll continue going. So that's not the solution now. And we'll save the 7. So, okay, let's start back here. So 15 and 2, this will actually be, start here. So 17, so we have So let's do the same thing. So we have 2 plus some value is equal to 17. That missing value is going to be 15, and we can find that by doing a subtraction, right? 17 minus 2 is 15. So we can save that in here, and we can save the index of this 2, and we can continue to the next value here. So 17 minus 7 is 10. So save that here, and save the index of the 7. And then at this, and I should also mention, so when we're at the 7, we're also going to do a get operation in here. So we're going to check the hash map to see if the pair exists in here. In this case, when we're at the 7, that was only the 15, so when we do a check for 7, it's not going to be in here, so we go to the next value. But okay, so we'll do that for this next value. So 11, we first check in here, is 11 in our hash map? No. So then we do our subtraction again. So 17 minus 11 is 6. And then we go to the next one here, 15. And now we do, is 15 in our hash map? Yes, it is right here. And so we know we can output 0 and also the index of this value, which is 3. So now we'll output 0 and 3. Okay. So now let's talk about the runtime here. So we said that so basically we do one iteration through our array, which is O of n time. And then we also, at each element, we do a check or a lookup in our hash map, and that's going to be O of 1. And we also do the subtraction and we insert into the array, into the hash map, but again, that's an O of 1 operation. So our total runtime is going to be O of n. All right, so let's go back here and let's code this up. So like we said in our drawing board, we're going to have a hash map, and we can just call this targets. And then we can now iterate through each element in our loop. So for each, let's just call it a num in nums, we're going to first check to see if the difference, or no, if this current num is in targets. So you check if num in targets. And if it is, then we're going to go ahead and return our solution, which is going to be the index of the two values that make up the pair, right? So that will be this current index, so we'll need the index here. So let's go ahead and enumerate. So this will be, we'll return the current index, and we'll also return the index of the previous value that we calculated. So that will be basically targets, and then the num here. Right? Okay, and then now we're going to do our for loop. So we're going to loop, oh no, sorry, not for loop. We're going to do our calculation, and we're going to insert into our targets hash map. So we're going to do basically the value target minus whatever number we're currently on, and we'll save the index. Right, so, and all of this logic is just coming from sort of the diagram that we went over. So we're basically grabbing the target, we're subtracting it by the current value that we're on, and then we're saving that index, right? Okay, so now we're going to basically return none. We'll never hit this case because we're going to always have a solution, but let's just do that. Okay, so let's go ahead and run through this now. Okay, so we pass all of our cases, and let's go ahead and submit. Okay, so yeah, this looks pretty good. All right, so that's it for this video. If you enjoyed this and you want me to create more videos like this, please like and subscribe, and then add in the comment section below what problem you would like me to solve next, and I can do that for you guys. All right, that's it. Thank you.